Hello everyone and welcome to Danomics. In this video we're going to review how to do the mineral inversion interpretation. Let's get started. At this point you should have already created your petrophysical interpretation. You will have set your key well and you'll have done the interpretation through the TOC analysis. At this point we're now ready to move on and do the mineral inversion. Now, within the mineral inversion, it should be noted this is an optional module. You're not required to perform this part of the interpretation. However, performing mineral inversion when you have the right data often provides you with a superior answer for porosity. And this is especially true when you have complex or mixed lithologies within your system. So let's take a look at how this works and what it does. When you perform a mineral inversion, it provides you with a mineralogy for your rock, and that mineralogy is then used to calculate a grain density. The grain density can be in turn used to calculate a total porosity without having to set a matrix density for your zones. So the mineral inversion, if you've never used this before, it's a bit different than some of our other interpretation modules and some of the other methods that you'll have used. And the best way to think about this is that we are providing a list of minerals that we think are available within our system. We're providing a list of curves that are available in Danomics. And then we are simply doing some matrix algebra to solve for our mineral volumes here. So that is the operation that is being performed. Now the layout on this is a little bit different than some of our other modules, and that's because we need to visualize this as essentially two matrices instead of a series of parameters. So when it comes to setting up your mineral model, you'll see that at first it says zone default, and this is our default mineral model. Now, what we want to do is we only want to select the minerals that we think are widely present in our rock. In this case, for most of my zones, I do not have dolomite or pyrite. So I'm going to turn those off by default. However, in a couple of zones, such as the Niobrara, where it's an organic shell, I believe that I do have pyrite available, so I'm going to reactivate that. And the same is true for the Maori. So once I've done that, I'm going to return to my default mineral model. And now I'm going to start to look at my curves. The way the QC works here, the way we understand if we have a good result from our inversion, is we look to see if our predicted curves that come out of the inversion match the input curves that we have. And we want to see them overlie one another, ideally, or at least fall within the uncertainty bands. So here we can see that with the sonic curve, we're not getting a good match here. So what we want to do is we want to come in and change the sonic property of some of our minerals. Now for most minerals, the sonic property is very well known. However, for some, it is not. So for example, the sonic can be highly variable within clays. So why don't we look at a cross plot to help us set this? So we'll make a cross plot, and we're going to make a custom, and actually instead of a custom cross plot, we're going to choose our DT clay. And what we see here is that if we look at most of our formations of interest here, so we're going to say all formations, what we see is that the sonic value of clay rarely ever exceeds 100. And even out here at samples that are 50, 60% clay, we see values that are around 85 to 90. So we're going to come in here to our matrix, and we're going to change our DT clay in this case to a value of about 95. When we do this, we see that the sonic value changes, and we now have established a much better fit between our predicted and actual sonic curves. We also have a little bit of a misfit between our neutron and our predicted neutron. Once again, this is an area where we can come in and set this for our clay properties here. So we're going to set this slightly higher in this case to a value of 0.4. And once again, we can see that we have a better fit between our actual and our default. Okay, now when we look at our curves, we see we have a really good fit, except for this curve here. This is our conductivity curve. The reason the fit is so poor is because by default, the conductivity curve is disabled. If you wish to use the conductivity curve in your fit, we can simply select to fit this. And now we see that we get a much better fit for our conductivity. However, we should go through and calibrate the conductivity both of our fluid and of our clays. So you can do this, of course, by using something like our RT clay cross plot, where you can come through and you can look at what the resistivity of our clays are. And in this case, you know, a value of 250, which means about 4 ohms of resistivity, is approximately the correct value. We could also set this for our water. And if you thought you had, if you needed to change this, you could select this to be either higher or lower based on your water salinity. Okay, so that is how we perform this correlation. Now, if you find that you need to have more controls, for example, let's say you wanted your pyrite volume to be based on a curve. So for example, if you had a correlation between pyrite and kerogen, you could go and add that correlation as a constraint. So by default, Danomics does have that correlation built in. And to apply that extra curve, we're going to say edit matrix. We're going to add a curve. And from our list here, we're going to select pyrite volume. You can select whatever curve you would like here, but we're going to use that curve by default. Once we're done, we're going to say done editing. And now we can see that in zones where we have kerogen, we now have a fixed ratio between our kerogen and our pyrite. You can also add minerals through the same process. You can say edit matrix, add a mineral, and you can either create your own custom mineral or you can select one from our drop-down menu. If you decide that you want to remove a mineral, you can remove it by clicking the X here. Once again, once you're through, you'll just say done editing. So now you have performed your mineral inversion within Danomics, and this has now been done for every well. This model has now been established for every well in your project. All right, if you have any questions on this, please feel free to let us know by emailing us at support@danomics.com. Thank you.